Hello everyone, today I will walk through our responsible AI approach for building a credit card approval model for ABC Bank. And our goal is not only to build an accurate model, but also to ensure that the system is fair, transparent, and aligned with responsible AI principles, which is critical in financial decision making. And the objective of this project is to predict whether a customer should be approved for a credit card. From a business perspective, this model supports three major goals. First, increase approval efficiency by allowing the bank to process applications faster. Second, reduce credit card risk by identifying applicants who are more likely to default. Third, ensure regulatory compliance and fairness, since credit decisions directly affect people's financial opportunities. Because of these regulatory and ethical considerations, accuracy alone is not enough. The model must also be fair, explainable, and auditable. And we began with EDA to understand the dataset. The distribution of the target variable and the relationship between features. The dataset includes demographic, employment, and financial indicators such as income, number of children, employee, and status, property ownership, and communication attributes. We also examine the missing value of the correlation to ensure data quality and to guide purposing decisions. And the data was split into training and testing set using a 75 to 25 stratified split to maintain the distribution of the approval outcome. And we can see over here. And we implied a purposing pipeline including median imputation for numerical variables, most frequent implementation for category variables, standard scaling for numeric features, one-hot encoding for category features. Using a pipeline ensure processing is consistent and reproducible, which is important for production deployment. And these three models we evaluate are logistic regression, random forest, and gradient boosting. The logistic regression provides a strong interpretability, which is valuable in regarded industrial. Tree-based models such as random forest and gradient boosting can capture nonlinear relationship and often improve predictive performance. We evaluate model using accuracy, F1 score, and ROC AUC. Among these metrics, ROC AUC is particularly important for this credit approval problem. Credit approval is a risk classification task, where we must balance false approval and false rejection. ROC AUC matrix the model's ability to separate approved and rejected applicants across all thresholds, make it more informative than accuracy only. The selected model achieves strong ROC AUC performance while maintaining stable result between training and the testing dataset. We evaluate fairness to ensure the model does not disadvantage protected groups. Especially, we analyze the model outcomes across gender group. We compare approval rate and recall rate between gender. Approval rate shows whether one group is approved more frequently than another, while recall measures whether the model identifies qualified applicants equally across groups. Large difference in these metrics could indicate potential bias in the decision-making process. And second, the fairness evaluation aligns with several responsible AI principles: fairness, transparency, risk mitigation. These principles are especially important in financial service. And to make sure the model explainability, we use three complementary interpretability techniques. So the first one is permutation. And the second one is Sharpe value. Sharpe value provides more detailed explanations by showing how each feature contributes to an individual prediction. For example, stable employment, high income, or poverty ownership may prove a predictor toward approval. This method helps explain individual decisions transparently. And for logistic regression model, coefficients include both the direction and the magnitude of each feature's influence on approval probability. Combining permutation importance, Sharpe value, and model efficiency approve a strong level of interpretability for both technical teams and the business stakeholders. And for business impact, the model provides several benefits. First, faster credit decision making, approval, operational efficiency. Second, the model helps reduce financial risks by identifying qualified applicants more accurately. Third, the responsible AI framework ensures transparency, fairness, and regulatory compliance. By integrating fairness evaluation and explainability to the system, reduce the risk of algorithm bias and reputational damage. So in conclusion, this project demonstrates how machine learning can be applied responsibly in financial service. And together, these steps align the system with responsible AI principle and support both business value and ethical decision making. Thank you.